So thanks everybody for being here to my masterclass. First, a quick few words. So you will get the slide deck at the end. There will be a short link. And also during my whole presentation, I built a lot upon the work of others. And when I reference somebody or something, there are always links at the bottom of the specific slides to give them credit, but also for your further research. So you do not need to write anything down. At least this was my goal. The only thing that makes maybe sense to write down are questions for the end. I've roughly planned to have 45 minutes of presentation, and then we should have enough time for questions. Okay, let's start. So I will take you on a little time travel because Toby likes time travels, but I'm doing them at the beginning, not at the end. So we are in the year 1913. Henry Ford was already a successful car manufacturer, but he was not a multinational corporation. And in this, we're now having a look at how they are producing cars in this year. So the cars were standing still, and all the workers moved around the cars. So they were building one car on one place, and it took like 12 hours to build a single car. And probably most of you know, Henry Ford then invented the conveyor belt, and it was a brilliant idea because instead of people going around the cars basically came to the workers on conveyor belts, and the workers specialized then on one single task. With this simple change, he then could produce 8 cars in 12 hours instead of just one car. So yes, Ford was a very smart guy, but it's very important to note Ford had not more capital than the others, and the conveyor belt was already invented by other industries, but it just leveraged it for mass production. And the conveyor belt and the specialization around it was not just working well for car manufacturing, it basically kickstarted the whole industrial revolution, and it became the dominating narrative for efficiency seekers of all kinds. The problem is just it does not work very well for knowledge work, because a lot of software engineering, I think, is stuck at this conveyor belt metaphor, creating waterfalls from time to time. But we still have a lot, even without waterfalls. I think we have too much specialization and silo creation. And I think the fundamental difference here is that building software is a design process. It's not working at an assembly line. Because when building an already designed car, the problem is already solved. The car is already designed. All the decisions are made. The workers then can optimize for efficiency. But when we're building software, we're not implementing a solved problem. We are solving problems. So we are making creative decisions like every hour of the day, basically. And to optimize this whole thing, we need to approach it from the perspective of a design discipline and not from a efficiency-seeking manufacturing discipline. So basically, we need to optimize how decisions are made and what freedom we give the people doing the decisions. Let's first start with a quick analysis of what's the state of the world today. There's a quote from Andy Hunt. It's already 10 years ago, and some things have changed since then, but not a lot. Because originally the coders around Andy Hunt and the one that made the Agile Manifesto, they had a plan, they had a vision, and those values, they are still true today. But during this presentation, I really tried to separate the values and principles of Agile from those of project management like Scrum. Because if you look at Scrum, this is the things in the green circle. This basically are business practices. This is not engineering practices. The engineering practices are the red ones, and the team practices are the blue ones. So we during the last, let's say decades, business took over in the form of Scrum and of other processes. ultimately, I think Agile became kind of a micromanagement tool. A PO gets a lot of requests, some normal requests, some urgent requests, and then he puts the urgent request on the backlog, and suddenly the urgent requests are planned urgent requests, and they are pushing down the work that was originally planned. So, and this causes then a situation where the developers need to do the trade-offs at the end because they are running out of time, and those trade-offs are maybe not with the same intention than the feature was originally. So shit is falling off at the end, and maybe we're producing not the best thing possible because we did not collaborate correctly on the right level at the right time. And I saw waterfalls even in the very smallest teams, and it's always caused by a drive for efficiency. So this is a graph by Stefan Schmidt. You maybe know it. It's also a German CTO. And he showed it very precisely, the drivers for efficiency, and then also the effects out of the efficiency. So when efficiency is the main goal, then everybody tends to work on his or her own, just optimizing for the own personal situation. And we end up with different development and product orgs, or also even design orgs. And yeah, then we have something like Scrum Fall or Waterflow, yeah. And yeah, in such a scenario, having the own design org or product org, for example, then we have designers inventing beautiful things. They're doing 30, 40 Figma screens and all makes sense in their head. But then once we implement the design, we are either out of time or it's not even possible at all to implement those things. But it's not just from the design side. The problem also comes from a developer side regularly. So developers also forcing others in creating silos, and silos are very easily generated by tickets because it's the ultimate silo wall. One side writes the ticket, the other side implements the ticket, and everybody just stops thinking at their edge of the reality and not a step further. There are scenarios where the ticket system makes sense, but it's not when building collectively interdisciplinary a feature together. It's more like to manage bugs and reactive work. But I will come back to this. But let's imagine we are in a silo. We could maybe also see the positive sides in a silo. I mean, if I'm in a silo, I imagine I could work for 8 hours undisturbed, and I just do my own thing, working on tickets. But this is not how reality is. Everybody interrupts and disturbs somebody else all the time, and somebody cannot get something done without interrupting 5 different people via Slack. They are focusing on their thing at the time. So we have this hyperactive hive mind working mode, and to get something done that seems easy from a silo perspective now gets suddenly very, very complicated. And there's also the AI hype train. The AI hype train on the communication side, I think, will not help us here totally removing those silo walls. And the AI train from the product side makes it even more complicated because now suddenly AI and UX needs to work together to actually build good products, because how many AI products are out there with just a very, very bad UX? So to repeat maybe a little bit, building software, this my definition, means making decisions in continuously evolving systems. So we are a design discipline, we're not a manufacturing discipline, but the environment is also constantly changing. So we need to rethink how people are making decisions and who is doing which decision with whom. So, and basically knowledge work is ripe for a revolution like the Industrial Revolution more than 100 years ago. And nothing less is my motivation for this talk. Since my very first company 15 years ago, I'm always challenging how people are working together and how work is sliced. And I came up with kind of a framework. Let's call it a framework for decision making, but not decision making on a very tactical level. It's more like, how can we slice the work, align the teams to make that the right people make the right decision? And how can we scale this? Of course, a couple of layers for a whole org. And also, how can we emancipate the people to act like this? So let's start with slicing the work. There's a quote from Ryan Singer. He's the inventor and author of Shape Up, and he says, "So much complexity in software comes from trying to make one thing do two things." This is why for slicing work, it's not just slicing work, it's basically 4 different things that you can slice here. It's the slicing of objectives, the slicing of problems, slicing of solutions, and also the slicing of delivery, ultimately. The slicing of objectives conceptually is the easiest thing. You just force rank it. Like either the team is focusing as an objective that focuses on engagement or on growth, but not both. In theory, this sounds easy, but we all know how hard it is to discuss those kind of requirements and objectives with stakeholders or the rest of the company. But it's fundamental for everything else, because when a team is having conflicting objectives already to start with, then everything else is getting harder. The next one is about slicing problems. And for slicing problems, it's very important that we don't confuse problems with solutions. A problem definition, like this is also from Ryan Singer, he called it framing. The problem definition just means what is the current context of the user and what is the desired outcome? How does the future look like for the customer when we have addressed the problem? But it's very important at this early step that we don't confuse a discussion about solution here. For example, there could be somebody is proposing the customer needs a Kanban board, but this is not a problem definition. This is already a solution. So it's very important to distinguish those two things, and that a good product manager is then diving in, finding out where does this requirement come from? Why does the customer want a Kanban board? Does he have a completely different problem? Maybe he just wants to be informed that something's changing. So it's just problem definition is just from A to B and not how do we get from A to B. And this is also a good segue to the company strategy or to jobs to be done, whatever we use to find out what the customer is actually wanting. But another concept from Ryan Singer is the concept of appetite. So this is from Shape Up. Normally, we do estimates. Estimate means fixed scope. Somebody has an idea of what to build, then the engineer is estimating it, and then we always end up with variable time because it just things happen that we did not know before we start with the work. And the opposite here is an appetite. Like we first think, how long should something take? Like we have a fixed time, but we keep the scope flexible here. And then you could also use this as a good communication technique with your team, because if you ask them, what would the version look like that we can solve in 1 week? It's a completely different conversation you're having than how would the version look like that we can do in 6 weeks. So you can use this as a tool. You don't think, you really start with how long do you want to allocate resources to something, and then you keep the scope flexible. Because if you keep the scope flexible, you can guarantee quality. This is what we all want, right? And you can also guarantee cost and time. You just keep the scope flexible. But how to keep the scope flexible during implementation? It's about the right way of slicing solutions. And here all is about de-risking. If you look at it on a very high level at the beginning from a project, you have a lot of uncertainty and you have a lot of time left. And you want to reduce the uncertainty as time progresses. So you really try to reduce the most uncertainty and the biggest unknowns at the beginning of a project. And to do this, it's not enough that just the product manager is doing this or whoever writes the requirements. It's very important that the product design and engineering is doing those process of de-risking together, like they're doing at the beginning, the strategic, centralized, and all aligned decisions together. And at the end, the smaller details with less uncertainty, they can then be left to the team actually implementing it. So it's very important to fight discussing about details too early, but on the same time, you really need to diffuse some things that could blow up during the development time. And yeah, one thing you could try with your team is just start at a blank slate and let them collaborate. You give them a well-defined problem, context, desired outcome, and yeah, let them just figure it out. No wireframes, no 30, 40 Figma screens, no specifications already. They need to come up with everything with the rough shape of the project together. And they need to do it collaboratively. Because then you have a whole different view on the thing. Because when somebody prepares something, then I'm looking at it and I'm nodding and I think, yeah, it probably makes sense. And I don't have time to actually dive deep and question too much. And it's from my perspective as an engineer. So people stop thinking if they are presented with too much information already. So if you are working on a solution, it's very important that everybody is part of this solution development together. And by the way, on the top right corner, you see this experimentation symbol. I have this on a couple of slides for quick things you kind of can try out tomorrow, maybe in your teams. Behind this process, there is the so-called diamond of participation. Maybe you have heard of it. It's from a book called The Facilitator's Guide to Participatory Decision-Making. And I think we all know this from brainstorming. You have a divergent zone and then you have a convergent zone at the end. But in between, especially if you look at teams, at interdisciplinary teams, there is a long grown zone where actually the work is happening. And here it's very important that you just take the whole team along for the whole ride, that they need to be part of the divergent zone to come in this collective decision mode together. So it's very important to take everybody along. Another technique from ShapeUp is something called breadboarding. Breadboarding, if you know it from electronic tinkerings maybe, it's about finding the right elements. So you find a resistor, you find a transistor, maybe you use some existing components like an USB port in this case, and then you wire it up basically to find out what parts are you need before you build a large-scale PCB or something like that. And the same thing you could do for an application. You do breadboarding in Miro, for example, or on a real whiteboard, just to find the high-level interaction flows. So it does not matter what's there in detail, but there's just a very basic convention of pink stickies are places and yellow stickies are affordances. And this is a question, if you start at a blank slate with a senior engineer, senior designer, senior product, to just find out how should the solution look like, then everybody can participate and everybody can draw an arrow or remove something or add a sticky. And here's very important to activate everybody in the team. So in my current team, we have introduced something we call round robin. We all know it from CPU scheduling, but you can also use it in a collaborative workshop setting. So everybody makes one move, adding one sticky, or sometimes a couple of them is also okay, but not some individual is preparing the whole thing. It's like everybody is just making one sticky and then it's the next turn and then the next turn, and then you can also remove things from others, but it's some way of guiding the guiding the creative process where you activate the silent ones and you prohibit that the louder speakers are dominating the whole thing, and you give enough time for everybody to think and also act. It works very well. It's I would call it the ultimate weapon to activate introvert engineers. And then in such a setting where you collaborate, at one point, all of the knowledge is on the board, then there are homework, some call it spikes. And if you do spikes before you go into the next such session where you collaborate, it's very important that the people don't just answer a yes/no question. It's really they need to take everybody along with them. What did they do? Did they build a prototype? Do they talking with customers to get more data, or are they challenging some assumptions with existing data? So it's very important to not just have a yes/no conversation here, because as in the example before, you want that the whole team is taking everybody along on the ride. But it doesn't need to be Shape Up. Those were just examples from Shape Up. If you look at how big tech is doing it, they're calling it a 6-pager, they're calling it an RFC, or they're calling it a design doc, but the fundamental process is the same. So like they are collaborating on an initial idea, and then they are iterating on it. So nobody is mentioning Scrum or anything here, yet they are living the agile principles very well, doing continuous deployment and everything. Something else you could try, try building a whole feature initiative without a backlog. Just, as I said, you give a well-defined problem to the team and then you give them a fixed time box of 6 weeks and let them have a little bit of a startup feeling for 6 weeks and see what comes out at the end. For slicing solutions, it's also very important that you slice them in a way that they are always ready to cut, because you cannot work differently within this fixed time box. You need to start with the most important things, with the unknowns, like in the graph with the uncertainty, and then you structure how you approach the project in a way that you can always stop and you're still delivering most of the customer value, or the scopes with the biggest customer value. What is the definition of a scope? I aligned on the definition of a scope that is something that is shippable in isolation, and it's done when it's deployed and when it's tested. It's not that you prepare something and then you prepare another thing and another thing, and then you have 2 weeks of testing at the end. This is not how a team really works together, because then they're just preparing things and then they may be missing their time box at the end. And it's very important then, and this is the segue to slicing the actual delivery, is that they work on it end to end. Like if you only prepare front end, nothing works. If you prepare a little bit here and there, also nothing works. Only if you have front end and back end or design, then something works. And this is what I mean with implementing by structure, not by person. You don't want, even if it's just 3 individuals, you don't want them to create their mini waterfalls in the 6 weeks. Very important, you always circle them back that they are working on the same thing at the same time. This is not a 100% possible in most of the cases, because designers sometimes need to think laterally and sometimes big picture, but like the 80% of the work should be at the same time end to end. So if you're looking at how to slice the work, objectives just one at a time, slicing problems, clearly defined problems out of the objective. So, and also important that there are not too much of dependencies in between of the problems you're tackling, because then it's hard to implement them in parallel with a lot of smaller teams. And also, yeah, as I said, the solutions need to be sliced and addressed in a way that you can always cut off, and then you slice the delivery one slice of the layer cake at a time. So this is now also the segue to the next chapter, how to align the teams. Here I start with Conway's law. You probably know it. Organizations produce designs that mirror their communication structure. It's from Conway. It's already from the 60s. Really amazing. And this is not just something that's interesting retrospectively. If you look how you ended up with a certain architecture, this is very important to use it also as a tool in aligning the teams to how you want your architecture to be. Another concept, important concept here, are the empowered product teams. So product teams, empowered product teams, as defined by Marty Kagan, are teams that are responsible for outcomes and that are also cross-functional. Because if you're pure cross-functional teams, but you only work on a roadmap and somebody else is defining what you're working on, then you're just a feature team implementing features, and you cannot close the loop to the problem you're actually solving. And the same is for a pure developers team. A pure developers team has not the capabilities to work on something else than on an output. But just the important thing on this slide is you can build across functional teams, but you need to make them responsible for the outcome, for the problems. You give them problems and not a roadmap with solutions somebody else came up with, a stakeholder or whoever. And the definition of a product team is there's a product manager. This is not a PO. A PO is a role in Scrum. This is really somebody who's knowing how to do user research, knowing how to talk to customer, doing jobs to be done. And this person then is responsible for customer value and also responsible for the business viability risk. Business viability risk, most of the people just think this is about, doing an Excel sheet, calculating if it will be profitable at one point. But it's more like this. It's a lot like, does it work for the business? Is it working for the go-to-market strategy? Because this is the most important thing that is often overlooked. And also other parts of the business that are interfacing with the product. Then you have a designer responsible for usability risk and experience. You have the engineers that are responsible for the feasibility risk and the delivery. And when you have all those risks, then inside of the team covered and they are fulfilling their role, then you can steer such a team just by objectives. You give them objectives. They are doing the discovery, problem discovery, solution discovery, and then they're doing the delivery based on it. And then suddenly such an interdisciplinary team is the smallest unit of planning for if you plan for outcomes. Another important model here is the team topologies. It's a book from Matthew Skelton, and it's another perspective to look at a team that should have everything that it needs, but it's more from the customer value perspective. So, for example, if you divide your team along some specializations like front and back end, you have a pure front end team, a pure back end team, then you have a lot of handovers, and not one single team can implement a feature from beginning to end. So what you rather want is a team that has all the capabilities it needs from the idea to the actual delivery. This is what Matthew Skelton means with stream-aligned team. They're aligned towards a full value stream. But this is not just for front and back end teams. This could also be a problem for companies that are too siloed in their product thinking, in their architecture, going back to Conway's law. So if you have a different team for your catalog, for your checkout, for your payment, for your fulfillment, whatever, then you have also a lot of handovers in between if you want to implement one thing from beginning to end. So here you also need to think in terms of capabilities. And team topologies goes a lot deeper. I can really recommend the book. There's a lot more about the supporting structures that allows such a stream-aligned team to work in this way. But this is just a high-level overview of the concept. Another interesting way of thinking of how to configure teams is something that I stumbled upon just recently, I think at the end of last year. It's the idea of capability teams. Like I just had the examples of functional teams and cross-functional teams before, but one step further means you don't need to have strictly specified roles for like, this is a back-end engineer, this is a front-end engineer. There could be full-stack engineers. There could be people doing product and some coding. So the idea is that you cover all the capabilities of a team, but you don't need to have it in separate roles. And a stream-aligned setup gives you much more flexibility in doing something and ultimately allowing the individuals to grow further for what they're interested in. There's also, going back to the step of in-sourced engineering, it's also important that you don't have an agency in the mix, because an agency could be a black box it's not under your control, and their employees will never feel like your own or as part of the team. But you could try is, if you want to end up with something like a capabilities team, hire and foster interdisciplinary roles. For example, Postdoc, they are famously known for only having product engineers, calling them product engineers. They're looking for engineers that are customer obsessed, they know how to use data, and they're always prototyping and experimenting. So they're looking basically for CTOs of failed startups most of the time. But I think there are also other individuals out there that could, not just the product and engineering crossovers. Another interesting law is Brooks' law, and Brooks' law says communication scales exponentially. So if you have 3 people, then you have 3 lines of communication because everyone is talking to 2 others. If you have 7 people, you already have 6 lines of communication, and so the communication scales exponentially. This is why I always try to, going back into the idea of making the right decisions with the right people, that it's not too many people involved in decisions. So going back to the Scrum fall, you have mostly of time with a long UX phase, long UI phase, and then you have large teams of developers just having 2-week sprints, and they have their bugs and their requests, and they're out of time on doing then the trade-offs at the end. So what's a better model of thinking about is that you optimize for smaller teams that ultimately can work in longer cycles, like the 6 weeks from ShapeUp, for example. So you're doing the de-risking in a group of 2 to 3 people, senior product engineer and designer, and then you do the delivery in a team of maybe 2 engineers, 1 designer. And you always then have 2 to 3 people talking to each other and not too much people involved into everything. And then they can do the trade-offs all the time. To enable such a setup, it's important that you also have an enablement layer, like it needs to be defined who is responsible for the reactive work. This can just be implemented by 1 or 2 people responsible for all the ingoing tickets. And this allows the rest of the team then to actually be free to have 2 or even 3 delivery streams running in parallel. And this is the best practical way to enforce work in progress limits, because they are doing the reactive work. They can really focus on 1 ticket at a time. They don't have this overhead of working on a feature and doing bugs and doing customer onboarding at the same time. And for the delivery teams, it's the same. They're having 1 project, and within this 1 project, they're working at 1 scope at a time. So always bring together the 2 to 3 people relevant for something. Maybe try out removing your backlogs altogether, or only use it for reactive work. And then basic Kanban is enough. You don't need 10 columns of QA and product manager, green lighting, and all kind of those things. Another thing you could try is just de-risk the changes. Like we de-risk the projects, you de-risk the changes in your team setup, and you just experiment. This is something we introduced ShapeUp 2 years ago, and we just had half the team doing ShapeUp, and then a couple of weeks later, half the other part of the team is doing ShapeUp. And when you work in this mode, like having 3 people focusing on 1 thing for 6 weeks, not getting disturbed with anything else, and you do it with both parts of the team, then it's a very easy sell at the end of the day to work in this mode, because everybody likes working uninterrupted. Motivation for small teams ultimately is just the idea of startups. Again, it's small teams that work in long cycles, clearly defined problems, and shipping continuously. So how to scale this for orgs? Peter Drucker said, only what gets measured gets managed. So we need to find a way to measure what we want to get managed from the rest of the company. One thing how Basecamp is doing the measurement of their projects is they're having a thing called hill charts. The idea is progress is more like a hill than a straight line. And if you have all your scopes of the project arranged on a hill, then you know what scopes are uphill, like where the team is figuring things out. And then you also know where this work is downhill, like making things just happen. And then it's clearly to you as a leader, do they have a lot of unknowns left, or are they just writing code, basically? Another thing from Basecamp, just introduced recently, I think last year, is the idea of to differentiate between the progress and the time box. Like this bar here on the scale, it's moving along when time is progressing, but the needle is set to the project progress. So you can say the time is over for 60%, but the project is only done for 40%, and then you would mark it as concerned. And you also give a little bit of a text explanation here. And going back to the idea of Peter Drucker, if you implement reporting structure that basically enforces the habit of working scope by scope, then the team hopefully will work scope by scope, or the team will not work scope by scope, or is working or is having 10 different scopes in parallel active and nothing gets done. Then this is a way where you know that you need to intervene and help them and coach them to the right way. And yeah, also try something like roll-up dashboards, but for project progress. Those are some variants of moving the needle, how it could look like. And it's also another way of giving a good high-level overview without using Jira, for example, because Jira does not tell you this kind of thing. From a org structure, very important that you have trifectas, not only on the team level, but you have them for middle management and for senior leadership. Here, something you could try is hire and foster interdisciplinary leaders. So like I'm a CPTO covering product and engineering. This could also be true for other leaders in other parts of the organization. So bringing it together, to remind you, the goal is to have small teams. Trifectas are a small team by definition, just 3, but you have the small teams on this level and you have the small teams on the team level. And when you now map this whole thing to how we slice the work in the right way, you have the level of slicing objectives as a task for the senior leadership. You have slicing the actual problems to fulfill the objectives. This is then the work for the middle management trifecta, and then you actually slicing the solutions and the delivery on the team level. And important to say, this is an exchange. This is not just top-down dictate. It can also go up, because maybe if you're slicing the solution, you found out the problem was not well defined, and then you go back and you discuss it in this round. Last part of this presentation is about the emancipating the people. Also starting with a quote here, it's from Admiral Grace Hopper. She said, "It's easier to ask forgiveness than it is to get permission." Everybody knows this quote, maybe, but here's a fun fact for you. Did you also know that this is the woman who invented the term debugging? Just maybe you have learned at least one thing today. But what does it mean? It means you should do the right thing within your organization, whether or not they know it. Because sometimes maybe you're VP or director or not the CTO, you can always do the right thing, and as long as it profits the organization. When I named this chapter Emancipation on purpose, because I think it's very important that we are maybe stepping back a little bit from this wording of empowerment. Because when I'm thinking about, when I say to a team, you are empowered to this and to do this and that, then I feel like it brings me on a level above them, like in a position where I'm dictating something from above. So, but instead, I really try to believe in the creativity of each individual, so that they figure out how to solve the problems, and so that they can grow on each individually. And here it's very important that if you want commitments, they need to come from the team, like from the whole interdisciplinary team, and not you as the manager giving them the commitment. You need to be done by end of March or something like that. It's very important you give them the problem and maybe also the time box, and then they can commit to what they can accomplish in this time box. If you are too involved, then you are part of the problem, so to say, and you cannot hold them accountable because you were part of it. So this is why you need to get a step away, get a step back, and let them come up with the commitment. There's also this notion of, or this feeling at one point in my career, I had it, that senior tech leadership, it's more about facilitation and facilitating shared learning and not having all the answers. Like, as I said, sometimes you need to take a step back and let the team have their own experiences, but you need to define where the room is to have the experiences. If you want to learn more about facilitating as a manager, this is Klaus. He is very into the topic of facilitation as for technical leaders. So he has also a nice blog and a newsletter you can look if you're interested in this. And also you need to step back, but you also need to have a good feeling on when you need to step in again and asking the right questions. There's a very good book called The Advice Trap from Michael Bungay-Stanier. And yeah, it does not help making you a certified coach, but it just helps that you stay curious a little bit longer than immediately jumping to the answer. Something very concrete you could try, and even tomorrow, is working with memes. Like what I did when I identified some memes or patterns of behaviors that I wanted to boost inside of the team. Then I created very shitty ChatGPT badges and I put them on Miro on the whiteboard. Like currently we have this a problem for later, including the ChatGPT typo or enough, let's move on. Elmo, I did not know this. Somebody from the team brought it up. But I just spotted those points where the team was moving into the right direction, doing the things that I would like to reward. And then I created those badges and I added them to Miro, and then I was helping the meme basically to get into the world. And yeah, we also have cut the scope, or yeah, this is a time bomb here. We need to diffuse. And now, after a couple of cycles, all those a couple of batches are always ready on a Miro where we are de-risking our work. And yeah, last but not least, the transformation to a new way of working will always come with tensions. And this is something you need to accept, but maybe this is something even you should celebrate. So because it's very normal, everybody tries to fit into a new process, so it's healthy. For example, when a designer is not doing their 30 or 40 Figma screens anymore, but needs to adjust the way of working, focusing on one thing at a time, then it's very important that they complain in a way, but not just complaining, but maybe also directly coming up with an idea of how to do it better. If they're not doing it on their own, you need to coach them to come up with those kind of ideas. And yeah, this goes back to the coaching mindset. And even I have seen a lot of teams during my career, but I don't get everything right from the beginning. So I always try to give the team a starting point, also process-wise. But if somebody has a different opinion, I'd be very public with praise for them for speaking up and thinking about improvements and ultimately proving me wrong. Because I think it's only in this way that you can really give a good example that it's okay to make errors as long as you learn from them. So yeah, going to the direction of the last words, important to break silos, not people, because if you want to change people, you genuinely must care about the people in your team. So start somewhere. A good starting points I already had in my presentation. It's shape up, it's team topologies, it's empowered product teams. So please start with only one thing and not all of them at the same time. And then just optimize for having the right people making the right decisions. Because yeah, they are doing decisions the whole day and they are the ones closest to the problem where a decision is needed, or you need to rearrange everything that they are the closest, and that give them also the freedom to make those decisions. So I forgot the introduction. I put it at the end. Just quickly, I started my career as a CTO of a digital agency. I co-founded directly after these studies. Then I was the CPO and CTO of an influencer marketplace called Buzzbird. And then I built up an industrial Internet of Things business unit for Void. And currently I'm leading product and tech at Edding, the company with the markers. And here are we building digital business models in a non-digital company. So comes with its own challenges. And yeah, so that's me. That was the presentation. I'm a startup founder with 2 exits in my interim gigs, trying to infuse startup culture into corporates, but I would not limit myself to any one of those labels. So, and I would definitely not call myself a consultant or something like that. Basically, I'm picking up challenges I found interesting along the way when they arise, and I prefer working hands-on, but also reflecting a lot, gathering a lot of materials and sharing them in talks like this or on my blog, VO1IO. And yeah, feel free to subscribe or follow me on LinkedIn. And also, please don't hesitate to reach out. I really like 30-minute or more coffees in the Alpha List community to just discuss challenges to each other. And yeah, here are the slides already online. Now we have really 10 minutes for questions.
Okay, very cool. Thank you so much, Klaus, for that. Just like a good wrap up of like everything that Ryan usually shares, and then some additional context and additional thoughts. I actually like it more than Ryan's talk, but also I heard it.
Don't tell it to him.
Yeah, I think he's good with feedback. Okay, so we have 2 questions in the Q&A section. And then if someone else has a question, you can also just raise your hands and ask. I would start maybe with David. Do you want to ask yourself, or you want me to read it out? It doesn't matter for me.
I can read it again. So thanks, Klaus, for the presentation. I really liked it. Most of the things I've heard before, right? But you put it all in context and reminded me about things like, yeah, true. That's the thing, right? Especially the team topologies. I still have to on my rereading list, right? So my question was around UX and designers in the team, right? Because I think it makes a lot of sense to have these integrated. But in my experience, when the engineers want to start working on something, they usually want to have something that's almost ready, at least, right? So then the designers would always work ahead, like a week or 2 or sprint or however you want to call it, and that then still would result back into waterfall, right? Did you also experience that? Do you have any ideas on how to solve that, or is it still okay because the team cohesion is still happening? What's your take?
So if the design, you're completely right. If the designers are 2 weeks ahead, then this is waterfall. One important thing, the role of the designer is really the hardest role here, because it's in the perfect scenario, this is part of the building team, but the working mode is a little bit different than purely from the engineers. So it's very important to have a design system in place and the component library, because also in Figma, but also in the code, because this speeds up the way for how both parties can work together. And the designer definitely should not work 2 weeks, should not be 2 weeks faster. It's more like the job of the designers is happening in 2 parts of, like, you have this phase of where you de-risk the project, like where you define the interaction flow on a high level. Here the designer kind of as spikes is moving a little bit faster, like is using one afternoon to maybe make a really rough wireframe. But in our case, the designer is not sharing this wireframe this is not something that gets discussed, but it's just helping the designer to ask the right questions in the session. And the same goes in the implementation phase. The designer is a little bit ahead, I would say a day or so in our current case. So not too far, because then you would need to throw away too much things if you change direction. But really, engineers do not need to wait for a design. Engineers can start by, because if both have the same understanding of what components we are needing, then the engineers can start bottom up. They can say, we need to refactor this table component anyway, and then the designer is designing the table component, and then then it's coming together, and then you implement the new table, and then you can test the table with a couple of different data, and then you can finish the table component, and then you do the next thing. Normally, when design system is there, the designer is faster than the engineers, and this gives the designer this 1 or 2 days that the designer needs to be ahead of thinking, menu structure and those kind of things. And what we also did when the designer was not possible to make some decisions, that we scoped them out. For example, in our current cycle, we have a problem with icons. The designer is not feeling comfortable selecting icons before she does not know what's up all to come. And so we're scoping out the icons to the end, making it a separate scope. We could ship it even without icons, but it would not be perfect. But just that we still can finish the scope, just being a little bit flexible here about the solution.
Thank you.
Cool, thank you. Sebastian, you want to go next?
Yeah, sure. Thanks for the presentation, first of all. I was wondering if you had any more insights on the reporting structure in those teams. You showed the team topology there. Would you say that interdisciplinary teams should have like some kind of manager within the team that the entire team reports to, where they also have a chance to incentivize and do performance reviews, for example, on like everything that happens within the team? Or should that be separated by the different disciplines, like, let's say, back-end, front-end, design, or product? How have you organized it, and what are your insights here?
Yeah, this is a very interesting topic. At one point in one team, for example, I really tried to what we did was we basically created a table of for what points are the team is responsible, like for vacation planning and so on, and for other points where engineering manager or director or so on is responsible, like for getting in the next level of pay grade and so on. So it varies from team to team and from structure to structure. And I think ultimately for performance reviews, you really need to have both components. You need to have an aspect from their daily work in the team. You need to have the 360 feedback, but you still want, as an engineering manager, like in the general sense, director and so on, you need to be in connection with the org you're responsible for. You need to have the direct connection with your org, but you also need to have the other part of the team.
Okay, so you need some kind of mixed model that incorporates just different feedback, but like still a very, like, let's say, traditional reporting structure that follows your technical skill set, basically.
Exactly. Yeah.
Oh, thanks.
Yes, but there's no easy answer, and you basically at a certain level you need to build your own model or process that just works best for you, like you're developing your own dev tools at one point.
Okay, if no one else has a question, there is one last. It's about, because you showed, I think maybe one time, the UI Basecamp, and are you using Basecamp internally?
No, we're not using Basecamp. Like at Edding, it's a complete remote team, and so this means we're using Miro for everything. So for feature building, we use the Kanban board inside of Miro, and then we have Confluence, and we also have a Jira for the reactive work. This is where the bugs are going and everything, but we don't use Jira for feature development. For feature development, it's really just one Miro for one shaping initiative, where we have the scopes, where we have the whole process of how we got to the scopes, like if everything is related to the project on one board, and then we also do the actual, the team is organizing itself there basically by themselves.
Okay, if no one else has a question, we are right on time. And I want to say thanks, Klaus, for sharing that.
Yeah.
And I want to highlight, if anyone else wants to do a masterclass, it's really highly appreciated. We also share it later. If you want, we do share it later on the AlphaList YouTube channel. And yeah, just in general, thanks, Klaus, and feedback and like follow-up stuff. And I think also the slides should be in the channel later, right?
Yes, I directly sent them.
Cool.